U.S. Navy MQ-25A Stingray refueling drone completes second test flight toward carrier service. The U.S. Navy's MQ-25A Stingray aerial refueling drone has completed its second developmental test flight, bringing the world's first carrier-based autonomous aerial refueling aircraft closer to operational service. Boeing Defense announced on July 10, 2026, that the successful test further strengthens the Navy's ability to extend the range, endurance, and combat effectiveness of its carrier air wings through autonomous aerial refueling. During the flight, the MQ-25A successfully performed its first airborne landing gear cycling, validating a critical function of its autonomous flight control system ahead of future carrier operations. As the program progresses, the Stingray is set to reshape carrier aviation by freeing manned fighters from the tanker mission, allowing them to focus on strike, air superiority, and other high-value combat roles. The latest flight expands the Boeing Defense MQ-25 as aerial refueling drone growing envelope of tested capabilities following its maiden flight earlier this year. According to Boeing Defense, the successful execution of landing gear extension and retraction while airborne demonstrates increasing confidence in the aircraft's systems integration and confirms progress toward meeting the demanding operational requirements of catapult launches and arrested recoveries aboard U.S. Navy aircraft carriers. The milestone is particularly significant because reliable landing gear operation is fundamental for safe carrier aviation, where aircraft are subjected to far greater structural loads than during conventional runway operations. The MQ-25A Stingray represents one of the U.S. Navy's most significant aviation modernization programs in decades. Unlike previous unmanned aircraft developed primarily for intelligence, surveillance, or strike missions, the MQ-25A has been specifically designed to restore organic aerial refueling capability to carrier air wings. By assuming the tanker mission currently performed by manned Boeing FA-18EF Super Hornet fighters equipped with buddy refueling stores, the Stingray will free valuable combat aircraft for their intended strike, air superiority, and fleet defense roles. His shift carries major operational implications. Today, a significant percentage of Super Hornet flight hours are devoted to tanker missions rather than combat operations, reducing the effective striking power available aboard every deployed carrier strike group. Once fully operational, the MQ-25A is expected to substantially reduce this burden, increasing the number of mission-ready fighters available for offensive and defensive operations while simultaneously extending the operational endurance of carrier air wings. The aircraft's autonomous flight control architecture is central to this transformation. Unlike remotely piloted systems that require continuous operator control, the MQ-25A employs highly automated flight management, capable of executing complex flight profiles with limited human intervention. During carrier operations, this autonomy will be essential to safely conduct launch, recovery, navigation, rendezvous, and refueling in one of the world's most demanding aviation environments. The successful landing gear cycles performed during the second test flight represent considerably more than a routine systems check. Carrier aircraft landing gear must withstand extreme impact forces during arrested landings and support repeated catapult launches under maximum gross weight conditions. Validating the mechanical operation, hydraulic systems, sensor feedback, and software integration during flight is therefore a prerequisite before progressing toward more demanding carrier suitability testing. Boeing is producing the MQ-25A under a contract awarded by the U.S. Navy to deliver the initial operational fleet of unmanned refueling aircraft. The program is expected to provide more than 70 aircraft over its production life, equipping future carrier air wings with dedicated unmanned tankers capable of transferring thousands of pounds of fuel to naval aircraft operating hundreds of nautical miles from the carrier. This significantly expands the combat radius of carrier-based tactical aviation without requiring additional manned support aircraft. The Stingray's design reflects its specialized mission. Powered by a single Rolls-Royce AE 3007N turbofan engine, the aircraft incorporates a blended fuselage, high-mount wings, and an optimized internal fuel capacity tailored for aerial refueling operations rather than low-observable penetration missions. Although not designed as a stealth aircraft comparable to the U.S. Navy's future sixth-generation combat systems, it has aerodynamic efficiency and endurance that make it ideally suited for persistent tanker operations over maritime theaters. The aircraft is also equipped with a Cobham aerial refueling store, enabling it to refuel Navy fighters such as the FA-18EF Super Hornet, the Lockheed Martin F-35C Lightning II, and the Boeing EA-18G Growler. This interoperability is expected to enhance the operational flexibility of future carrier strike groups by allowing multiple aircraft types to receive fuel during extended missions deep into contested operational areas. Beyond aerial refueling, the MQ-25A has been designed with sufficient growth potential to accommodate future mission expansion. U.S. Navy officials have previously indicated that the aircraft's architecture could support additional payloads, sensors, communications relay capabilities, or intelligence, surveillance, and reconnaissance equipment should operational requirements evolve. Such adaptability aligns with the Navy's broader vision of integrating autonomous aircraft alongside manned aviation assets within a networked carrier air wing. The program also serves as a technological bridge toward the U.S. Navy's future family of carrier-based autonomous aircraft. Operational experience gained through the MQ-25, including autonomous deck handling, command control integration, maintenance procedures, and human-machine teaming will provide critical lessons for future unmanned combat aircraft expected to operate from aircraft carriers alongside next-generation crewed fighters under the Navy's evolving air wing modernization strategy. Industrial progress on the program continues in parallel with flight testing. Boeing has established dedicated production facilities to support low-rate initial production while simultaneously advancing developmental testing required before operational evaluation. Each successful flight incrementally reduces technical risk as engineers validate software, flight controls, propulsion systems, and structural performance across increasingly demanding operating conditions. From a broader strategic perspective, the Boeing Defense MQ-25A aerial refueling drone represents far more than the introduction of a new unmanned aircraft. It fundamentally changes how carrier aviation generates combat power by reallocating manned fighters from support duties to frontline missions. In an era characterized by growing anti-access and area denial threats across the Indo-Pacific, extending the reach of carrier-based tactical aviation without increasing fleet size offers a significant operational advantage for U.S. naval forces. When combined with future unmanned systems and next-generation naval aviation initiatives, the Stingray is poised to become a foundational element in transforming carrier air wings into more distributed, resilient, and combat-effective forces capable of operating in increasingly contested maritime environments.